Good morning to you all. This is my small good morning to you all. This is my small video on micro teaching on the subject on origin of nanoscience for the refresher course on sustainable development, Dr. Baba Sahib Ambedkar, Marathwada University, UGC HRDC. Next slide, please. So, nanoscience is a multidisciplinary field that explores phenomena and manipulates materials at the nanoscale, which is typically defined as a range of approximately 1 to 100 nanometer. The origin of nanoscience traced can be traced to several key developments in science and technology. So, what was the early concept of microscopy? So, the earliest linkages of nanosciences date back to ancient times when humans first began using materials on nanoscience. However, a systematic exploration began with the invention of microscope in the 17th century. So, Liu Hoker's development of high quality lenses enabled the observation of microorganisms. So, origin of nanoscience about a half of century in 1959, eminent physicist Richard Feynman described the future of prophetic lecture about physical possibilities on making and manipulating, visualizing and controlling things on a small scale and imaging them in decades to come. It might possible to arrange the way we want. So, nanoscience over the next 40 years by overcoming these the different scientific constraints in different fields, nanoscience and nanotechnology. So there are two main approaches or origin of nanoscience can be best. You can say that on two approaches. In the bottom up approach, materials and device are built from a molecular components which assemble themselves chemically by principles of molecular recognition. And in the top-down physical approach, nano objects are constructed from larger entities without atomic level control. The bulk material is evaporated due to the impact of confined plasma in the introduction plasma torch at a very high temperature. Under controlled environment, it rapidly solidifies and it passes through the quench zone, which permits the synthesis of highest quality, clean spherical metal, ceramic, and composite nanopowders. Due to shock of quenching, the supersaturation of a vapor provides the driving force for nucleation ultrafine nanoparticles. So, next slide. So, let us talk about the materials used in nanotechnology, that is fullerenes and nanotubes. So, all you know that carbon exists in a large number of allotropic forms. This includes diamond, graphite, a variety of discrete molecules such as cobalt 60, cobalt 70, etc., which are collectively known as fullerenes. Fullerenes or carbon nanotubes are a class of allotropes of carbons which are obtained by rolling up graphite sheets into spheres or tubes as shown in figure. Depending on the way graphite sheet has been rolled up, they have different names as as well as on the basis they behave the metal or semiconductor. These macromolecules are unique for their size, shape, and remarkable physical properties. Carbon nanotubes are the strongest and stiffest material yet discovered in terms of tensile strength and elastic modulus. Due to so that nanotubes are of the big interest for their mechanical strength and electrical properties. So C60, also known as buckyball, is the smallest member of the fullerenes family for the past decade. The chemical and physical properties of fullerenes have been a lot of topic in the field of research and development and are likely to continue to be for a long time. So, in 2003, fullerenes were studied under the potential medical use binding specific antibiotics to structure of resistant bacteria and even targets certain type of cancer cells such as melanoma. It can be used also as a light activated antimicrobial agents. So let us talk about nanoparticles. Second figure shows that nanoparticles is a nanocrystals made up of metals, semiconductors, or oxides are of the particular interest for their mechanical, electrical, magnetic, optical, chemical, and other properties. Nanoparticles have been used as a quantum dots and as a chemical catalyst. Nanoparticles are of the great scientific interest as they are effectively a bridge between bulk materials and atomic or molecular structure. A bulk material should have constant physical properties regardless of its size, but the nanoscale, this is often not the size dependent properties are observed, such as quantum confinement in semiconductor particles, surface plasma, resonance in some metal particles, and super amalgamation in magnetic materials. Next slide. So let us talk about the different properties of nanoparticles. So we know that nanoparticles have enormous properties like surface effect, quantum size effect, optical property, electrical property, magnetic property, mechanical property, diffusion property. So let us talk about the surface effect. The surface effect properties of nanostructures are that bulk system has its origin in very fundamental physical property. In any material, atom on the surface behave differently from an atom in the bulk. The difference is mainly because of their potentials. Now, the size of the particle decreases in nanostructure. The number of atoms on the surface is in a greater proportion of the total number of atoms. So, the size of becomes smaller and smaller. Physical and chemical properties changes since the surface atoms start dominating the properties of the whole material, and that give rise to the difference in the properties of the nanoparticles and their applications with different fields. So let us see the second property of nanoparticles is quantum size effect. So nanoelectronics size of devices is in the range of the de Broglie's wavelength, that is lambda equal to h by mv, 1 nanometer equal to 10 nanometer. So of the electrons, so quantum size effects become relevant in these devices. This quantum size effect does not come into play an important role by going from macro to micro dimensions. However, it becomes dominant when nanometer size range has been reached. The uncertainty principle, delta x into delta p is greater than or equal to h, and or delta e into delta t is equal than or equal to h, is very important if we are considering nano electronic applications, because the dimensions of such devices are so small that we can use uncertainty principle to roughly estimate and relevant nano electronic effects. For example, the tunneling effect. Due to the disturbing influence of thermal energy, many quantum electronic effects are separated at low temperatures. So next property is optical property. So in a metal size of a particular decrease, there will be an oscillation of electron gas takes place on the surface of nanoparticles, which is known as surface plasmas. Now, when those nanoparticles are exposed to light wavelength, then comparable to their size and frequency close to that of surface plasma, then surface plasma would absorb energy from light, and nanoparticles shows a different colors as their size changes. Let us talk about the electrical properties of nanomaterials. Electrical property for any solid structure, the capacitance of the structure depends on the dimensions. As the dimension of the particle decreases, capacitance also decreases. Linearly, for a very small dimensions, the voltage change of the particle can be measurable even when a single electron added to it. This is known as Coulomb Backade effect, which utilized for making single electron transport. Magnetic properties. So magnetic properties of nanoparticles behaves differently than bulk materials. The dynamics of magnetization and demagnetization of any magnetic material in any devices are governed by the presence of domain walls and region having magnetization in different directions. So in case of magnetic nanomaterial, the magnetic vectors become aligned to the order pattern. So next, last property is diffusion property. So as we know, diffusion property in nanostructure, high surface area to volume ratio provides tremendous driving force for diffusion, especially at elevated temperatures. Sintering is possible at lower temperatures and over shorter durations than for larger particles. The surface effects of nanoparticles also reduces the insufficient melting temperatures. So some of the extra properties which nanoparticles are showing, that is scratch resistance property, agglomerism, some other properties like quantum dots and all. So let us stop here. Thank you very much.